Hello everyone. Today we'll be starting one new topic from steel structures, eccentric bolt connection. So, what are these eccentric connections? Many a time we come across a situation where the load coming into the connection is not constantly. What do I mean by constantly? That is, the CG of the load is not passing through the CG of the connection. Okay, as you can see in this figure, a column section. Okay, a column. This may be Indian standard heavy beam, Indian standard medium beam. Okay, is acted upon by a load of E, and which is at an eccentricity of E, and this we call a bracket. Okay, so due to this eccentricity, additional moment will come into the board, and that moment is equal to m equal to load multiplied by the eccentricity. Okay, so for this additional moment, we have to design the bolt and taking care of the eccentricity that the load is creating. Okay. Now, if we come into the analysis, if we come into the analysis, as you can see, there are 8 number of bolt in the connection, and a load of E is coming into the bolt at an eccentricity of E. Now, in analysis, we can divide this connection into two parts. That is, we can separate the moment that is coming due to the eccentricity P into E, and we can replace the load, eccentric load, into a concentric load in this. So by these two arrangement, we can represent this system. Okay. Now what will happen is this concentric load will apply a direct axial force on each bolt, and that axial load value will be F equal to P by N, and we assume that every load carries uniform load, so the total load coming into the connection will be divided into n number of parts, that is the number of bolts. So the direct load will be acting like this. In every bolt, there will be direct axial force of F equal to P by N, and the load due to moment will be acting radially. That means in this diagram there are 8 bolts. Let us draw the centroid of the connection. If this is the CG of this connection for this bolt, the force due to moment will be acting in radial direction. That means this is the radial direction, and the force due to moment will be acting perpendicular to the radial direction. So perpendicular, like in this direction, the force due to moment on this bolt will be acting. Similarly, force on this bolt will be, this is the radial direction, and perpendicular to the radial direction is this, it will be acting like this. Similarly, on this, it will be acting like this. Similarly, on this bolt, it will be acting like this. Why I'm drawing like this? Since the movement is in direction, so the rotation has to be in like this. So in next slide, you can clearly see what will be the effect of direct stress and direct force on the bolt and the force due to movement. Let me clear it first. So as you can see in this diagram, there are 6 bolts. So let me draw the centroid of the bolt. So in this case, the centroid will be passing through the bolts. The force due to moment will be acting radially. So as you can see, this is the radial axis. It will be like this, perpendicular the direction, like this, and so on and so forth. Since the moment is coming like this, so the direction should be like this on each bolt. And direct force, as I have shown you in previous slide, it will be downwards for each bolt as the load is coming like this. Okay. So combined effect, we can see that FA will be downward and force due to moment will be perpendicular to the radial direction. So for each bolt, if we draw this, it will be represented like this, and the resultant will be passing through the center like this for this bolt, and it will be passing through this, and for this it will be like this. So I have numbered the bolts number 1, 2, 3, 4, 5, 6. Now what we have to do, we have to analyze each bolt and we have to find the critical bolt which is susceptible to the failure. Now for this joint, if you see, you can see that the resultant force in one bolt and resultant force on the three bolt will be same. So one of them may be critical and resultant force on 2 and 5 will be same, so one of them may be critical. So when we solving one problem, we have to see, we have to judge which bolt can be critical, and if we try to find the forces on each bolt, it will take a lot of time. So based on our experience, and we have to judge which bolt will be critical, which bolt can be susceptible to the failure. Okay, so in next slide we will be seeing how to calculate the force due to moment. Now as you can see, let me draw one first. So, okay, so the direct axial stress on bolt will be Fa equal to P by N, that we have already seen in previous slide. Now we have to keep one thing in mind, that the force that will be force due to moment is proportional to the radial distance from the CG of the connection. Okay. Now if this is the CG of the bolt connection, the radial distance of each bolt from its CG will decide what is the amount of force that is coming onto a single bolt. Now, for this bolt, this is the radial distance. Okay, so this distance will decide what is the amount of force due to moment coming onto the bolt. Okay, now we can represent Fm is the force due to moment on bolt. Fm is proportional to the R. We can write it as Fm equal to K into R. K is the proportionality constant. Okay. Now, this is the force due to moment on each bolt. Now, the moment will be force multiplied by the distance, and distance will be radial one. So we can write moment on each bolt is Fm multiplied by R. Now, if we sum up all the moment on bolt, we will get the total moment. Then total moment can be represented as Nt equal to summation of Fm dot R. And Fm can be represented as K into R. So we are simply replacing Fm in Kr, and simply we can write K, we can take K out of the summation and K into R square, and K can be again represented from this equation Fm equal to Kr, so we can write K equal to Fm by R. So we have written K equal to Fm by R summation of R square. Now from this to this we can write Fm equal to Mt into R by summation of R square. So by this formula we can find forces on any bolt, force on any bolt due to moment coming due to the eccentricity. Now we have to find the eccentricity, we have to find the resultant force on each bolt as the direct, as we can see in previous slide, the direct axial load and force due to moment making an angle for some of the bolt, like bolt 1, bolt 3, bolt 4, bolt 6. So for this kind of bolt, we have to take the vector sum due to vector sum of force due to moment and force due to direct load. But for bolt 2 and bolt 5, they are in the same direction, so we can directly take the scalar sum, that is resultant force will be Fa plus Fm for this bolt 2, and for this resultant force will be Fa minus Fm. Okay, so for bolts where the moment force due to moment and direct force are making an angle theta, so there we have to take, there we have to calculate the resultant force with this formula, Fr equal to Fa square plus Fm square plus 2 into Fa into Fm into cos theta. What is this theta? Theta is the angle between these two force. So this is Fm, and this is Fa. So this angle will be theta. We can calculate once we can calculate this theta. Once we'll solve one problem, we'll see how to find the force due to moment on any bolt and force due to direct force on each bolt, and we'll be able to find the resultant force on any bolt. Okay. In next video we'll solve one problem based on this theory. Thank you.